This is Chapter 3A on listing outcomes and creating diagrams. In this chapter, we will learn 3 skills. Number 1, how to draw a tree diagram, how to draw a sample space diagram, and also understanding the differences between a sample space diagram and a tree diagram. Now, first of all, here's 3 key words you need to understand in this chapter. The word trial, which is a statistical experiment, such as when you just simply roll a dice, you spin a spinner, you flip a coin. These are just experiments. They're trials. When you do something, it's a trial. An outcome is a possible result. So if you pick a card, you might pull out a 5 of hearts, you might pull out a joker, or if you roll a dice, you might roll a number 2, maybe you roll a number 6. If you flip a coin, maybe the coin lands on heads, maybe it lands on the other side, which is tails. So those are outcomes, possible results. An event is a collection of outcomes. So what are the results? What are the possible results of throwing an odd number when you roll a dice? An event could be flipping heads when you flip a coin, rolling a 3. So these are events, the collection of your results. So first, let's talk about tree diagrams. A single-stage tree diagram, a 2-stage tree diagram, and a multi-stage tree diagram. So just to give you an idea, a single-stage tree diagram is when you only have one set of branches, only one set of outcomes. So in this case, you roll a dice. Draw a tree diagram to show the possible outcomes. So when we roll a dice, there's 6 traditional dice, there's 6 sides. So there's 6 outcomes. Here's outcome number 1. You hit a 1. Outcome number 2, you roll a 2. Outcome number 3, you roll a 3. Outcome number 4, you roll 4. Outcome number 5, you roll a 5, and outcome number 6, you roll a 6. So that is a single stage tree diagram. There's only one set of branches, as you can see. Here, 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 here. So this is your first outcome. Now in a 2-stage tree diagram, you're going to have 2 sets of branches. So you roll a dice twice. So in this case, you have your 6 outcomes for the first roll. 1, 2, 3, 4, 5, 6. And your numbers are 1, 2, 3, 4, 5, and 6. And then your second tier is basically branching off of your first outcome. Now today you're going to have to excuse the writing on my screen, as for some reason it's just not working today. But let's continue with the content. So in the first outcome, you have a possibility of rolling a 1, 2, 3, 4, 5, or a 6. Now, when you roll the dice the second time, the outcomes are still the same thing. There's no change. So what we do is we branch off of each number from the first outcome. So if you roll 1 and you roll the dice again, then in your second outcome, you can get a 1, 2, 3, 4, 5, or a 6. Now, if you roll a 2 in your first outcome, your second outcome is also 6 different outcomes, 2, 3, 4, 5, and 6. For your third, if you rolled a 3 in your first outcome, your second outcome could also be 1, 2, 3, 4, 5, 6. And it continues in this way where there's always 6 outcomes, because in this case, we're rolling a dice. So a 2-tiered tree diagram has 2 layers of branches. You have the first layer, which is highlighted in red, and then you have your second layer, which is basically highlighted here in blue. And so to find out the total number of results, well, in the first stage, we have 6 outcomes, because 1, 2, 3, 4, 5, 6, there's 6 outcomes. And in the second stage, since we have 6 the first time, and we have 6 the second time, then you have a total of 36 outcomes possible, because 6 times 6 makes 36. Now, a multi-stage tree diagram is basically more branches. So if you roll the dice 3 times, then you're going to have your first set of outcomes, which is 6 outcomes, 2, 3, 4, 5, 6. Your second set of outcomes, which is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and it's going to continue that way. And then you branch off of the second set of outcomes for 6 more, 1, 2, 3, 4, 5, 6. So realistically, if we draw this, it would fill the screen. But to find the total number of outcomes, we multiply the total outcomes for each round. So in the first round, we can get 6 different outcomes. In the second set, we can get 6 different outcomes. In the third set, we again have 6 sets of different outcomes. So in total, you have 216 different sets of outcomes possible in a 3-stage tree diagram. So again, single stage, 1 set of branches, 1 set of outcomes. 2-stage, 2 sets of branches, 2 sets of outcomes. And you multiply the total number of outcomes for each round to get your total. And in multi-stage, well, it depends on how many, but again, you keep branching off until you get all your outcomes. So now at this time, go ahead and pause and try to do these 3 exercises. Okay, so if you flip a coin twice, to see your outcomes, your first set of outcomes, you can either land on a heads or you can land on a tails. In your second set of outcomes, again, you can land on heads or you can land on tails. Now, if we landed on tails, we can again land on heads or we land on tails. So in total, 2 times 2, you have 4 total sets of outcomes, because here's a way to look at it. You can, if you flipped a head for the first time, you can flip a head the second time. If you flipped a tail the first time, you can flip a head the second time. If you flipped a head the first time, you can flip a tails the second time. Or if you flipped a tails the first time, you can flip a tails the second time. So in total, there's 4 different combinations, and we can write these out just so that you can see it more clearly. You can get a heads, heads. You can get a heads, tails. You can get a tails, heads. Or you can get a tails, tails. Now, if you flip a coin twice, if you roll a dice, then you flip a coin. So your first set of branches is 2 branches for heads. You roll a dice, 6 branches. 1, 2, 3, 4, 5, 6. Please excuse that. Let's redo that one more time. 1, 2, 3, 4, 5, 6 for your 6 dice. 1, 2, 3, 4, 5, 6. And then you flip a coin. So if you flip a coin, you only have 2 outcomes. So this is your second set of outcomes. So if we flipped we rolled a 1, we can have either a heads or tails for the second round. And then same thing, if we rolled a 2, we can get heads or tails, heads or tails, heads or tails, heads or tails, heads or tails. And so in the end, you have 12 different outcomes because you can get a 1 in a heads, 2 in a tails, 3 in a heads, 3 in a tails, 4 in a heads, 4 in a tails, 5 in a heads, 5 in a tails, 6 in a heads, 6 in a tails. So there's 12 possible outcomes. And then finally, you're passing through 3 traffic lights. So when you pass through the first one, you have 3 colors you can pass: red, yellow, green, or orange for some of us. And when you pass through the second set of lights, again, you have 3 choices. 1, 2, 3. 1, 2, 3. Then you pass a third set of lights, again, 1, 2, 3. 1, 2, 3. 1, 2, 3. And it continues in this manner. So if you think about your total outcomes, 3 times 3 times 3, you'll end up with a total of 27 different outcomes. So here we have a sample space diagram, and sample space diagrams only allow you to compare 2 sets of choices for your possible outcomes versus like a tree diagram, we can go more than 2. We can go into 3 stages, multi-stages. But sample space diagrams only allow us to have 2 choices to work with, 2 sets of outcomes. So situation 1, you take a French and math test on the same day. Either you pass or fail. Draw a sample space diagram to show the possible outcomes. So what you do is you create a rectangle, and on one side you label it math, and on the other side you label it French. Now either you pass or fail. So in math, either we pass or we fail. In French, either we pass or we fail. So now what you have to do is just tell us what the possible outcomes are. So in math, you can pass, you can fail, you can also pass, you can also fail. Now for French, you either pass or you fail here. Sorry, my mistake. You either pass or you pass, because this line right here represents P, or you fail and you fail. So the combinations you have here are 1, 2, 3, 4. So either you pass your math test and your French, or you fail one and pass the other, or you pass and then fail, or you fail both. So there is 4 total outcomes. And the same thing, if you just do 2 times 2, you have a total of 4 different outcomes. In the second situation, your cat eats twice a day. He has a choice between tuna, chicken, or beef. Draw a sample space diagram to show the possible outcomes. So you draw a rectangle, and one side represents meal number 1, and the second side represents meal number 2. He has 3 choices: tuna, chicken, beef. So for meal 1, chicken, tuna, or beef. Chicken, tuna, or beef. Meal 2, he has 3 choices: chicken, tuna, or beef. Now you just have to write down their options. For the first meal, you can have chicken, tuna, beef, and you continue filling out the table in this way to show the first meal. And then the second meal, he can have chicken, and I'm going to fill it in straight across. This is tuna, because this is the T line. And then this is the B line, the beef line. And so when we look at the combinations, your cat can have chicken, chicken, tuna, chicken, beef, chicken, or chicken, tuna, or tuna, tuna, and so forth. So in total, we have 9 combinations, 9 possibilities, possible outcomes. And if you think about it again, if you go 3 times 3, that does make 9 total outcomes. So at this time, go ahead and pause and try to do this situation here, where your football team plays 2 games this weekend. Either you win, lose, or draw. Draw a sample space diagram to show the possible outcomes. So this is what you do. You draw your rectangle. You have game number 1. And then you have game number 2. In game 1, you either win, lose, or draw. In game 2, you either win, lose, or draw. Now fill it in. Win, lose, draw. Win, lose, draw. This is for the first game. And then in the second game, either you win all the way across, lose all the way across, or draw all the way across. And so in total, you have 9 different possible outcomes. And there's only 1 out of 9 chance of winning both. And now just to summarize, similarities and differences between both of these diagrams. The similarities, they both compare different sets of outcomes. So cat food, meal 1, meal 2. They both help create a thorough list of outcomes. So if you try to actually create a list, sometimes we miss something. That's why we use the diagrams to help us organize our thinking. And 3, both of them show the outcomes of 2 events. They can show the outcomes of 2 events. However, here's some differences. A sample space diagram can only strictly show the outcomes of 2 events. So more meal 1, meal 2, game 1, game 2, test 1, test 2, French test, math test, only 2 things. Tree diagrams can record single or multiple things. So you can see the first traffic light, or if you roll the dice once, or if you roll the dice 3 times. You can even do it 2 times. So tree diagrams have a lot more flexibility, but yes, they do take up more space on your paper. And then 2, when you have multiple outcomes for a single event, such as pizza toppings, if it's strictly 2 events, the sample space diagram is more visually friendly. So, for example, if you want to choose toppings for your pizza between a list of cheese, chorizo, mushrooms, pineapple, that's a lot of things. Imagine trying to do a tree diagram for that. That would just take over your whole paper. So in this case, I would recommend a sample space diagram because it's more clear. It's easier to work with. You can see everything. And that's it.